Hello future doctors, welcome to MEMONEET. I am Sarthak. I am currently a master student at IIT Roorkee and your chemistry educator at MEMONEET. So before we start with the solutions and explanations for the full test 1, I'd like to say a few points to all of you. The Brahmastra Test Series that we have launched, it's our attempt at giving you an actual NEET-like experience. The entire content team has worked very hard analyzing and going through hundreds of papers to give you the most relevant and the best questions from the point of view of your preparations. So, and also the unique OMR scanning feature, it's just the cherry on the top. Make the most of it and attempt the tests like you're actually appearing for your NEET examination. Okay. So now I hope you have all attempted the full test 1 and scored good. But if you haven't, so tension ki koi baat nahi hai. Don't get disheartened. These tests are for your practice and we'll go through the explanations to eliminate any problems that you are facing. Okay. Any additional problems or doubts, you can ask me in the comment section and I'll address it as soon as possible. So let's get started with the video. So first we have section 8. Question number 51. The question says, which of the following statement is incorrect? Statement 1 says, the effect of the Heisenberg uncertainty principle is significant only for motion of microscopic objects and is negligible for that of macroscopic objects. So this is a correct statement because in Heisenberg uncertainty principle, we only talk about the microscopic objects, which are kind of like our electrons and our other subatomic particles. While if we apply the formula for macroscopic objects, the value of the uncertainty, we get that in the range of lower than 10 raised to the power minus 25 to 10 raised to the power minus 30. So the uncertainty is not very significant, so it can be neglected. So the statement 1 is correct, so this will not be our answer. Taking a look at statement 2, it says in multi-electron atoms, energies of the orbitals in the same subshell decreases with the increase in the atomic number. So this is also a correct statement, so this will not be our answer. Statement 3 says probability density, which is psi square, has no physical meaning. So this is an incorrect statement because psi square, which is the probability density, what does it tell? It tells us the probability of finding an electron in a given region around the nucleus. So it does have a physical meaning. Okay. Whereas if the question asked me about psi, which is the wave function, so psi does not have any physical meaning. So that would have been a correct statement. However, in case of psi square, it has a physical meaning and it represents the probability of finding an electron. So statement 3 will be our answer because it is an incorrect statement. Moving on to the next question. The question says, it's an assertion reasoning type question. So the assertion says the pKa of acetic acid is lower than that of phenol. So first of all, we have to understand what does pK compare. So pK compares the acidity. Okay. So more is the acidity. So if the acidity is more, so the Ka value will be higher because Ka is the equilibrium constant for the dissociation reaction. So if we have a stronger acid, so its Ka will be higher. So if Ka is higher, okay, so if acidity is higher, so Ka will also be higher. But if we take pK, so what is pK? It is the negative log of Ka. So the pK value will decrease. So when the assertion is saying that the pK of acetic acid is lower than that of phenol, so it is trying to say that the acetic acid is a stronger acid. So this is a correct statement. So the assertion is a correct statement. And why is that? The reason says phenoxide ion is more resonance stabilized than acetate ion. So this is an incorrect statement because what happens when we have the acetate ion, which is formed after the loss of a proton. So it looks like, so this is the acetate ion. So when resonance is occurring in this, what happens is, if I draw its resonance structure as well, so what happens here is that I get something like this. So if I take a look at these resonating structures, so these are equivalent resonating structures. So equivalent resonating structures stabilize the ion a lot more. Okay, so when we have equivalent resonating structures, so the resonance stabilization increases by a lot. So the acetate ion, it will be more resonance stabilized as compared to the phenoxide ion. Okay, so the reason statement is incorrect. So the correct answer becomes assertion is true but reason is false, which is option 3. Moving on to the next question. The question says identify the incorrect statement from the following options. Okay, so in this we are talking about the bond order and stability. So the first statement says bond order of O2 2 plus is greater than that of O2 plus. Okay, so this is the correct statement. How? I'll show you. For O2 plus, the bond order is 3, whereas for O2 plus, the value of bond order is 2.5. Okay, so what happens is when we are filling the molecular orbitals for oxygen for O2, so the last two electrons they are filled in an antibonding molecular orbital. So when we go from antibonding to when we go from O2 to O2 plus, so we are removing one electron from an antibonding molecular orbital, so the bond order becomes 2.5. And when we go to O2 plus, so we have removed two electrons from the antibonding molecular orbital, so the bond order becomes 3. So bond order of O2 plus is greater than that of O2 plus. Next statement says N2 plus is more stable than N2 minus. So this is also a correct statement because N2 plus because N2 plus in that we have number of electrons in the bonding molecular orbitals, okay, that is greater than that in the anti-bonding molecular orbital. However, when we go from N2 to N2 minus, so what is happening that one electron is being filled in the anti-bonding molecular orbital. So meanwhile, while N2 plus and N2 minus both have equal bond order, but N2 minus will be less stable than N2 plus because the number of electrons in the antibonding molecular orbital is increasing. Okay, so this will also be a correct statement, so not our answer. If we take a look at statement 3, it says bond order of O2 plus is equal to N2 plus. So this is also a correct statement. Both of them have a bond order equal to 2.5. And statement 4 says F2 is more stable than N2. Okay, so what happens in F2, in a fluorine molecule, we have a single bond between two fluorine atoms. The bond order is 1. Whereas in nitrogen, in N2, the atoms are bonded with a triple bond. So a triple bond is more difficult to break, and that makes nitrogen more stable as compared to F2 molecule. So statement 4 will be our answer. Moving on to the next question. The question says the rate constant for a first order reaction whose reaction rate is 0.06 at 10 minutes and 0.02 at 20 minutes will be nearly. Okay, so we are given a first order rate reaction, right? And we have to find the rate constant for that. So if we just use the rate equation, so the rate equation says that rate constant is equal to 1 divided by the difference in the time, and then ln R1 upon R2, which is the concentration of the reactant at initially divided by that in the final state. So when we substitute the values, T2, which is the final time, it's 20 minutes, whereas the initial time T1 is 10 minutes, and we'll convert it into second. Okay, so that we have to take care of because in this the rate is given in terms of second, so we have to convert the minutes into second as well. So for that we'll multiply it by 60 and then we substitute the values of the rate. So we get the rate constant as 1.83 multiplied by 10 raised to the power minus 3 per second. So the correct answer is option 1. Moving on to the next question. The question says, which of the following is the most stable free radical? Okay, so if we take a look at this, so we have 4 different free radicals. So we have to tell which of the following will be most stable. So we know that the things that stabilize the free radical, first of them is delocalization. So so the more the delocalization, more will be the stability. Also, the free radical can be stabilized by hyperconjugation as well, but mostly it will be stabilized by delocalization. So if we take a look, here we have hyperconjugation from 3 alpha hydrogens as well as a delocalization due to this double bond as well, right? In this case, in option 2, in molecule 2, we have a delocalized due to a double bond. In molecule 4, we don't have any kind of stabilization or delocalization. Whereas if we take a look in option 3, so in this we can see that the free radical, it goes into conjugation with this double bond, which further goes into conjugation with this additional phenyl ring as well. So there is a lot of conjugation. Due to this extensive conjugation, the compound in the option 3 will be most stable free radical here. So the correct answer will be option 3. Moving on to the next question. The question says, which of the following statements is incorrect? Statement 1 says the formal charge and bond order of NO3 minus are -1 and 4 by 3 respectively. So if we talk about the formal charge of the NO3 minus molecule, so here the formal charge will be equal to the total charge which is present in the molecule. Okay. If we calculate the formal charges separately for all the atoms, so they'll be different. But when we talk about the formal charge of the entire molecule, so it is same as the formal charge, which is it is same as the charge of the entire molecule. So that will be -1 because NO3 minus is carrying a negative sign. Okay. And if we talk about the bond order, so what is happening in NO3 minus is that the nitrogen, it is bonded to 3 oxygen atoms, right? And there is one negative sign here. So what is happening is this negative sign, it's in conjugation, and all of these 3 bonds, they have a partial double bond character. So apart from these one bond that each nitrogen and oxygen is forming, so there is an additional double bond character as well. So the double bond character is shared with between all 3 bonds. So what happens is this extra bond is 1 by 3, right? It's equal to 1 by 3 for each bond. So if we talk about any of the following NO bonds, so it will have a bond order equal to 1, which is the single bond, plus the partial double bond character, which is 1 by 3. So it gives us the bond order as 4 by 3. Okay. Moving on to the next statement, it says XCF4 is formed in the first excited state. So this is an incorrect statement because XCF4, it is typically formed in its ground state, not in the excited state. So what happens is when xenon is in its ground state, it has 8 valence electrons, right? And it forms bonds with 4 fluorine atoms. So XCF4 is formed. Okay. So XCF4 is not formed in the first excited state. The correct answer will be option 2. Sorry, it's the incorrect statement. So that will be the correct answer, option 2. If we take a look at other statements as well, so it says the melting point of NaCl is higher than that of LiCl. So statement is also correct because whereas we know that LiCl, it has a stronger lattice enthalpy, but still the melting point of NaCl is higher because of the high polarization of the lithium ion. Okay. And if you talk about the solubility of LiF is lower than that of Li of lithium iodide. So this statement is also correct. So moving on to the next question. The question says de Broglie wavelength for electron is related to the applied voltage as. Okay. If we take a look at the formula for the de Broglie wavelength, so it is given by lambda is equal to h, which is the Planck's constant, divided by under root of 2m ke, where k is the kinetic energy. So if I try to write down the formula for kinetic energy in terms of the voltage, right, because we have to find out the relation between de Broglie wavelength and the applied voltage. So if I substitute kinetic energy, so it can be written as the product of the charge multiplied by the potential which is applied. So when we substitute, we get the equation for the de Broglie wavelength as lambda is equal to h divided by under root 2m ev. So when we substitute the values of h, which is the Planck's constant, the mass of electron, and the charge of the electron, so we get the final answer as 12.3 divided by root v angstrom. Okay. So the correct answer will be option 2. Moving on to the next question. The question says, which of the following conditions is not required for aromaticity? And let's see the statements. So statement 1 says planarity of cyclic structure. So if we talk about aromaticity, so we know that for a compound to be aromatic, we need 3 to 4 conditions which have to be satisfied. First of all, the system should be completely conjugated, and the system should be a closed system. First of all we should have a closed system. Second of all, the closed system, the ring, it should be planar. Okay, when the ring is planar, only then we can proceed further. So after the planarity is ensured, the entire compound, it should be completely conjugated system. Okay, all the double bonds and all the atoms should be in conjugation with each other. And after that, we need 4n plus 2 pi electrons. Okay, the 4n plus 2 pi electrons should be conjugated in the ring. So that makes a compound as aromatic. But if we have 4n pi electrons, okay, if we have 4n plus 2 pi electrons, that makes the system aromatic. But if we have 4n pi electrons, it makes the system as anti-aromatic. For example, if I consider benzene ring, right? So in the benzene ring, I have 3 double bonds. Okay, so 3 double bonds, they will have 6 pi electrons. So 6 pi electrons can be considered as 4n plus 2 pi electrons, right? Where if I put the value of n as 1, so it will fall under the category of 4n plus 2 pi electrons. So that gives us a stable aromatic system. However, if the conjugated electrons are equal to 4, or equal to 8, so in that case we get an anti-aromatic structure. Okay, so the condition which is not required for aromaticity is statement 3. Okay, the presence of 4 and pi conjugated electrons, that is not required for aromaticity, that makes the compound as anti-aromatic. Moving on to the next question. The question says, given the electron gain enthalpies of three halogens X, Y, and Z as minus 349, minus 333, and minus 325, what is the correct order of these halogens? Okay, generally we might look for a trend happening, but in case of the halogens, we have a exception in the electron gain enthalpies, because since fluorine is the most electronegative, so we'll think that it will have the highest electron gain enthalpy, but that is not true because of the very small size of the fluorine atom. Okay, so fluorine is very small in size. So what happens is in its valence shell, the valence shell electrons, they are very close to each other. So when an electron is trying to enter the molecule, so what happens is there is a slight repelling. Okay, the valence electrons repel the incoming electron, whereas in chlorine the size of the valence shell increases, so there is a lot less repulsion, whereas the electronegativity of chlorine is also very high. So chlorine will have the highest electron gain enthalpy, which is minus 349, so that makes X as chlorine. And bromine, right? Bromine is large in size, but it also has it has low electronegativity as compared to fluorine, so it will have the lowest electron gain enthalpy, which makes bromine as molecule Z, and Y will correspond to fluorine. So our correct answer for X, Y, and Z will be chlorine, fluorine, and bromine, which is option 2. Moving on to the next question, we have question number 60. It's a very simple question. Okay, you don't even have to think much in this. So it says that in the given redox reaction, how many H2O molecules are produced per molecule of Cl2 gas? Okay, and we have been given the equation as well. And it's a very simple question here, because we don't even have to balance the reaction. It has given us OH minus plus Cl2, and it gives Cl minus plus ClO3 minus plus H2O. Okay, and if we take a look at this, we have Cl2. Okay, we have one molecule of Cl2 here, and it is giving us one molecule of H2O. Okay, so this is the wrong way of solving the question. Okay, most students do this, and that is why I did that. Okay, so just take care of that. Just don't go by this. What do we have to do? If we take a look here, okay, we have OH minus. Okay, so in the left hand side we have only minus one charge in total, but if I take a look at the right hand side, I have Cl minus and ClO3 minus as well. Okay, so on the right hand side I have minus 2 charge in total. Okay, so we have to take care of this. Students make this mistake when they see a question like this. That is why this question has been put, and that is why the reaction is also given. Okay, it distracts the students and they make a mistake generally. Okay, it doesn't happen in this question, but there are questions like this which are asked, so students tend to make mistakes. So we have to balance this until we get the charges at the left hand side and the right hand side as balanced. So when I balance the equation, I'll get 6Cl2, and they will be yielding at 6 water molecules. Okay, so if you made a mistake, so you are lucky that it doesn't bite you in the end, because in this 6 molecules of chlorine are giving us 6 molecules of H2O. So per molecule of Cl2 will have 1 molecule of H2O, but keep this in mind that we have to balance the charges and the negative signs always in a redox reaction. Okay, moving on to the next question. The question number 61, we have a sorry, we have a anisole, and it is being reacted with CH3Cl in the presence of anhydrous AlCl3. So as we can see, it is a Friedel-Crafts alkylation reaction. So what happens in a Friedel-Crafts alkylation? So we have CH3Cl, and we use anhydrous AlCl3, which is a Lewis acid. So it has a vacant orbital. So what happens is the chlorine atom in the CH3Cl molecule, it goes and attaches to AlCl3 to form AlCl4 minus, leaving behind a electrophile in the form of CH3 plus. Okay, so now an electrophile, it is going to attack on the benzene ring because it is very highly, electron rich. So due to this methoxy group present, so the methoxy group is orthopara directing for a incoming electrophile. So what will happen is that the methyl cation, it will either attack on the ortho or the para position, but due to steric hindrance on the ortho positions, the para product will be the major product. So the correct answer will be option 2. Okay, So moving on to the next question. So while moving on to the next question, I'll just like to say here that if you want, you can pause the video and take a 5 to 10 minutes break after every 10 questions, so that you are fresh and you just understand the questions very well every time. Okay. So if you want, you can take a small break here. Okay. And pause the video, take a 10 minutes break, come back and start off with a fresh mind. Okay. So I'll start with question number 62. The question number 62 says the optical activity phenomena is shown by. I have four different compounds, okay, and we have metal in the center, and it is forming bonds with A, B, and ethylene diamine radical. Oh, sorry, ligand as well. Okay, so we have to tell when the molecule will be showing an optical activity. So for optical activity, the molecule is supposed to be chiral. Okay, so my molecule should be chiral, which means that there should be no symmetry. Okay, so we should have no symmetry present in the molecule. And by that, I mean there should be no element of symmetry, which is axis of symmetry, center of inversion. None of those should be present. Also a plane of symmetry. Okay. So if any of those elements of symmetry is present, it means that the system will be optically inactive. So if I take a look at the option one, in this we can see that we can pass a plane of symmetry, right? So via all the B atoms and the M atom as well. Okay. So there will be a plane of symmetry in the X direction and also in the Y direction, cutting both the MA bonds as well. So statement option one will be not an answer. If I take a look at the option two, we can see that there is no axis of symmetry or there is no center of symmetry as well, right? The molecule looks as completely asymmetric. Okay, so this will be optically active because here we can see we have different groups attached on the top and on the bottom. Here we have A and below we have B. On the left hand side we have A above and B below, and if we take a look at the right hand side, we have an ethylene diamine molecule there. So there is no symmetry whatsoever in this compound. So option 2 will be showing optical activity. Still, if we take a look at statement 3, so in option 3 we have two ethylene diamine molecules on each side and A above and A below. So we can see that there is a plane of symmetry passing through this plane as well, and also through this plane, just like in the statement 1. So option 3 will not be optically active. And if I take a look at statement 4, here also we can see that if I pass an axis through here, okay, and if I rotate the molecule, so this is a axis of symmetry present, so this will also be not optically active. So the answer will be option 2. Moving on to the next question, the question says if a sparingly soluble salt AB with a molecular weight is given as 100, so it has solubility 1 milligram per liter. Calculate its solubility product. So we have been given a sparingly salt AB, and we have its molecular weight as well, and we have its solubility. We have to find KSP, right? So if I just write the dissociation or the solubilization of AB, so the AB solid, it will, when it solubilizes, it will be A plus and let's say B minus. Okay, so I'm just assuming that we can do that. So the solubility for A ions will be S, and for that, or for the B ions will also be S. So if I write KSP, it will be the product of the solubility of both A and B, so it will be S square. And the solubility is given as 1 milligram per liter. And we have to make sure that we convert it into moles per liter, because in the formula for equilibrium constants, we always use concentration in terms of molarity. Okay, we don't use gram per liter, we always use moles per liter. Okay, so when we have 10 raised to the power minus 3 gram per liter, we'll divide it by the molecular weight that we have given, which is 100 grams, and then we convert it into moles per liter. So we get the solubility as 10 raised to the power minus 5 moles per liter. So the KSP becomes the square of the solubility, which is 10 raised to the power minus 5 raised to the power 2, which gives us the KSP value as 10 raised to the power minus 10, which is in option 2. So the option 2 will be our correct answer. Moving on to the next question. The question says, which of the following represents the correct increasing order of acidic behavior? Sorry. Which of the following represents the correct increasing order of acidic behavior of the molecules given below? So the molecules that we have are ethyne, benzene, and hexane. So for acidic behavior, we know that there should be higher electronegativity and more stability, right? So more is the electronegativity, more will be the acidic character. So electronegativity in hydrocarbons can be seen using the S character. right? More will be the S character in the hybridization, more will be the electronegativity, and more will be the acidic behavior. So if we compare the S character, so in ethyne we have sp hybridized carbon atoms, right? So in sp hybridized carbon atom, the S character is 50%. In benzene we have sp2 hybridized carbon atom, so there the S character will be 33%, and in hexane we have sp3 hybridized carbon atom, so there the S character will be 25%. So the order of acidity becomes hexane will be least acidic, followed by benzene, and ethyne will be the most acidic of these given molecules. So the correct answer will be option 2. Moving on to the next question, the question says, what are the characteristics related to the magnetic properties and electron arrangement in the complex? And we are giving in the brown ring complex, which is FeH2O5NO Okay, so we have to find out the magnetic properties and the electronic arrangement. So first of all, we'll find the number of electrons in iron molecule, right? In the iron ion, right? For that, we need to find out the oxidation state of iron. So the entire complex ion, it is with SO4 2 minus, right? So the entire complex ion will carry a charge of +2. So water carries a charge of 0, whereas NO carries a charge of +1. So the oxidation state of iron will be Fe +1. Okay, so iron will be present in +1 oxidation state. Okay, so that means that we'll have S1D6, right? So we can write it as D7 as well. Okay, so iron is present in D7, which means that we'll have 3 unpaired electrons in the system, and for 3 unpaired electrons the magnetic moment can be calculated as under root n multiplied by n into n plus 2. Okay, so if we substitute 3 here, we'll get root 15 Bohr magneton as the dipole moment will be root 15 Bohr magneton, and as all the d orbitals will be filled up, so the hybridization will be sp3d2. Okay, so correct answer will be option 3. So correct answer for this is option 3. Moving on to the next question, the question says, for the reaction H2 plus I2 gives 2Hi, the Kc, which is the equilibrium constant, is given as 66.9 at 350 degrees Celsius, and Kc at 448 degrees Celsius is given as 50 degrees Celsius, as 50, sorry. Okay, so using the Van 't Hoff equation, we can find out the relation between Kc and the temperature. So it is given at ln Kc2 upon Kc1 is equal to minus delta H by R multiplied by 1 by T2 minus 1 by T1. Okay, so when we substitute the values, so here we can see that Kc1 is greater than Kc2, right? So Kc1 is greater than Kc2, so the value of this log, which is ln 50 upon 66.9, so this will be in negative, right? Because the value of the fraction is less than 1, so the value of the log will be negative. And since it is negative, on the left hand side we have minus delta H by R, and in the bracket we have the temperatures. Okay, so this term in the bracket, right, this term is also negative, and we have a negative sign here, so negative negatives gets cancelled. So for making the entire right hand side positive, so we'll need delta H to be greater than 0 to match the following answer. Okay, so delta H has to be positive, which means delta H greater than 0 as the correct answer. Moving on to the next question, the question says, the synthesis of alkyl fluorides is best accomplished by, we have 4 different options: Schwarz reaction, free radical fluorination, Finkelstein reaction, and Sandmeyer reaction. What most students make a mistake is that they uh, select Finkelstein reaction as the correct answer. However, Finkelstein reaction cannot prepare all types of alkyl fluorides, and for that case, we use Schwarz reaction. So it's a concept-based reaction, but it's a concept-based question, but there are many times students make mistakes here. So be careful. The correct answer will be option 1, Schwarz reaction. Moving on to the next question, the question says, arrange the stability of dihalides of silicon, germanium, tin, and lead in the following order. Okay, we know the inert pair effect, right? So as we move from top to bottom in a group, the inert pair effect becomes more and more predominant because of the weaker shielding effects of the lower lying orbitals. Like in the higher shells, we have d orbitals, f orbitals. So because of them, they are poor shielders of the nucleus. So the valence s orbital is held tightly by the nucleus, so those electrons are not easily used up in a reaction. So this is called the inert pair effect, and due to inert pair effect, uh, +2 oxidation state is more common in the carbon group as we keep moving down. So lead will be more stable in the +2 oxidation state as compared to tin, then germanium, then silicon. So the correct order will be silicon, germanium, tin, and then lead. So correct answer is option 3. Moving on to the next question. The question says, consider the following equilibrium. We have 2NO2 gas, which is brown in color. It is being converted to N2O4, and the enthalpy of reaction is given as minus 57.2 kilojoule per mole. Okay, so we have to tell the relation, the how the equilibrium will change when the temperature and pressure are changed. So for an exothermic reaction, when the temperature is lowered, so the reaction moves towards the forward direction. Again, when we have an exothermic reaction, so reaction moves towards the forward direction when temperature is lowered. Okay, so for this reaction, when we lower the temperature, so reaction will move forward towards N2O4, and N2O4 is colorless, so the brown color will be converted to colorless, so the intensity of brown color will decrease. So statement A will be correct. Okay, statement B says the equilibrium constant for reaction increases as the temperature increases, which will be wrong, because when the temperature will be increased, the reaction will move backwards, which will decrease the equilibrium constant. So statement B is wrong. So at low temperature, the brown color intensifies. It's a wrong statement. And if we talk about statement D, it says on increasing pressure, the reaction goes in the forward direction. So this is also true, because when we increase the pressure, so reaction will move in that direction where we have less number of molecules. So on the reactant side, we have two moles of gaseous molecules, whereas in product side we have only one. So the reaction will move forward when we increase the pressure. So statement D will be correct, giving us option 4 as the correct answer. Moving on to the next question. The question says, among the given compounds, the compound which is oxidized to prepare methyl ethyl ketone is. Okay. So first of all, we need to understand what methyl ethyl ketone is. Okay. So I've seen students make mistakes in drawing the structure of a methyl ethyl ketone. Okay. So what they think is that we have a methyl, we have an ethyl. So in total, we'll have only three molecules here, right? Only 3 atoms of carbon. So what they do is, some students make this mistake. Okay, so methyl ethyl ketone is CH3, CH2, C double bond O, CH3. Okay, so we have 2 butanol, that is known as methyl ethyl ketone. So to form methyl ethyl ketone, we just have to oxidize. If we oxidize 2 butanol, we'll get methyl ethyl ketone directly. Okay, so from the oxidation of butane 2-ol, we get butane 2-one. So the correct answer will be option 2. Moving on to the next question, the question says, what is the molecular geometry of ClO3? Okay, so if we talk about ClO3, we have chlorine as the central atom. It is bonded to 3 oxygen molecules. Okay, and chlorine has 7 valence electrons. So each oxygen will form a double bond, right? And there will be 1 extra electron. So that is why ClO3, it does not exist as a molecule. It exists as ClO3 minus ion. Okay, so we generally find it as chlorate ion. So we'll just take that into consideration. So when we form a double bond, there will be 3 double bond with oxygens and 1 lone pair. Okay, so this is what will be having the structure of ClO3 minus S. And as we can see that we have 4 total hybrid orbitals, right? We have 3 bond pairs and 1 lone pair on the chlorine. So for 4 bond pairs, we'll have sp3 hybridization, right? So the structure will be tetrahedral. However, due to the lone pair, the tetrahedral structure will be, if we take a look at the molecule shape, right? So it will look as a triangular pyramid molecule. So the correct answer will be option 3, triangular pyramid. Moving on to the next question. The question says, a gas is present in a rigid container at 300 Kelvin at and 1 atm pressure. If the temperature is increased to 600 Kelvin, it dissociates into B and C, and the reaction is given as A dissociating into B plus C. So and dissociation is given to be 50%. Okay, so we have 50% dissociation. We have to calculate the total pressure in the container in the final state. Okay, so what happens is, take care that we have been given 300 Kelvin and 1 atm, and we have to talk about the system at 600 Kelvin. So when we increase the temperature, the volume is constant, the number of moles is constant. So when the pressure is doubled, so what will happen, when the temperature is doubled, the pressure will also double. So at 300 Kelvin we had 1 atm pressure, so at 600 Kelvin the pressure will be equal to 2 atm. Okay, so at equilibrium, when 50% dissociation has occurred, so the pressure will be, for A it will be 2 multiplied by 1 minus the 50% dissociation has occurred. So 0.5 moles has been consumed. So minus 0.5. So we'll get pressure due to A as 1 atm, and B will be because 0.5 moles of A has been consumed. So B will be produced 0.5 moles. So that will give us the pressure due to B as 1 atm, and similarly C will be also produced as 0.5. So pressure from C will be 1 atm as well. So the final answer will be the total pressure is 3 atm, which is option 2. Moving on to the next question. The question says an organic compound with the molecular formula C3H6O forms an orange-red precipitate with 2,4-DNP, but it does not give tolerance tests. Okay, so we don't have the tolerance test, but we have a positive 2,4-DNP test. So the positive 2,4-DNP test, it is given by carbonyl compounds. Okay, so we have a carbonyl compound, that is for sure. So if we take a look at the options, so we must have a carbonyl compound, so we can eliminate option 2 and option 4. Okay, so now the question says that the compound does not give a tolerance test. Okay, so tolerance test is given by aldehydes. So if it is not giving a tolerance test, that means we have a ketone. So aldehyde is not the answer. Correct answer will be a ketone, which is option 3. Moving on to the next question, the question says, what is the cause of the bleaching action exhibited by SO2? So SO2 gives a bleaching action due to its reducing property. SO2 acts as a reducing agent, right? Which means that it will reduce the other substance. It will get oxidized still, and it will reduce the other substance by donating it electrons. So the reducing property of SO2 will cause a bleaching action. Moving on to the next question, the question says the work to be done on 2 moles of perfect gas at 27 degrees Celsius if it is compressed reversibly and isothermally. Okay, so we are given a reversible and isothermal process, and we have the initial pressure and the final pressure also given to us, and we have to find out the work done. So it is a very basic question, right? We just have to use the formula for work done in case of an isothermal reversible reaction. So the formula for work is given as minus 2.303 nRT log P1 divided by P2, which is the initial pressure divided by the final pressure. So we just substitute the values. We have 2 moles of gases, so N is equal to 2. R, we know the gas constant as 8.314, and the temperature is given to us as 27 degrees Celsius. So be careful to convert it into Kelvin first. Okay, take care of the units. That's the major mistake that most students make in physical chemistry. Okay, so 27 degrees Celsius will be equal to 300 Kelvin, and then we substitute the values of the pressure. So we get the final answer as 1.95 multiplied by 10 raised to the power 4 joule, which is option 3. Moving on to the next question, the question says the major product of the following reaction is, okay, so we have an ester and it is being reacted with excess of Grignard's reagent. So what will happen in this? Let's take a look at the mechanism. So when we have CH3 MgBr, so in the Grignard reagent, what happens is that magnesium, right? Magnesium is a metal, so it will try to go in the 2 plus oxidation state, right? So that means that the CH3 will be carrying a negative sign. Okay, so the methyl group acts as a nucleophile. So what will happen? It will attack the carbonyl carbon, which is highly electrophilic in nature. So what happens is when it attacks the methyl group, the carbonyl carbon, so the resonance takes place, and when this double bond oxygen opens up, so when it opens up, the negative sign migrates back into this bond, and the carbon oxygen bond is broken. Okay, so when the carbon oxygen bond is broken, so OR minus will be the leaving group and the CH3 will be attached. So this will form a, here we'll get an aldehyde, right? This is the aldehyde which will be formed. Now we have excess of Grignard reagent. So we'll have more nucleophile, right? So a CH3 minus will attack the carbon again. And when it attacks, so we'll get a Grignard's reagent complex. And when we hydrolyze it, so what happens is that Mg OHBr will leave, right? And we'll get a alcohol. The final answer will be propane 2-ol, giving option 1 as the correct answer. Moving on to the next question, the question says, what is the amount of thiosulfate ions in moles needed to fully react with 1 mole of permanganate ion in a slightly alkaline solution? Okay, so this is a question related to redox reaction. So we need to know the oxidation states from which the thiosulfate ion starts and it is reduced to, right? And the permanganate ion, from where it starts and where it ends in a slightly alkaline solution. So what a permanganate ion we have MnO4 minus, right? So in this manganese is in plus 7 oxidation state, and from here it goes into MnO2. In case of a slightly alkaline solution, it goes into MnO2, which is in plus 4 oxidation state. Meanwhile, if I talk about thiosulfate ion, so thiosulfate ion is converted into SO4 2 minus. Okay, so 1 mole of thiosulfate ions. Okay, so when we have 1 mole of thiosulfate ions, it is involved in the exchange of 8 electrons. Okay, so 1 mole of thiosulfate ions gives 8 electrons, and 1 mole of MnO4 minus, it actually consumes only 3 electrons. Okay, so if we have 1 mole of permanganate ion, it will be consuming 3 electrons, right? And 1 mole of thiosulfate will be giving 8 electrons. So to react 1 mole completely, so we need 3 by 8 moles of the thiosulfate ions. Moving on to the next question. Oh, here the correct answer will be option 3. Moving on to the next question. The question says the oxidation potential of hydrogen electrode dipped in a solution of pH is equal to 4 at 25 degrees Celsius and pH is equal to 1. Oh, sorry. The pressure of hydrogen is 1 atm. Okay. Sorry. Really sorry about that. So the pH is 4 and the pressure of hydrogen is 1 atm. So we have to find out the oxidation potential of the hydrogen electrode. So we'll just use the Nernst equation. So the reaction will be like H2 will be being converted into H plus, right? So the exchange of number of electrons exchange is 2. So that will be the value of n. So we just use the Nernst equation. We get E cell is equal to E naught cell. For hydrogen, hydrogen is considered as the reference. So the hydrogen reduction potential is 0. So E naught cell will be 0 minus 0.0591 divided by n. N is the number of electrons transferred, which is 2, and log of concentration of H, and it will be squared because we have a stoichiometric coefficient as 2 in the reaction. Okay, so H square divided by the pressure of hydrogen. Okay, so concentration of hydrogen we have to find out first of all, right? So if pH is 4, which means the concentration of H plus will be equal to 10 raised to the power minus 4. So substituting the values, we get the E cell as 0.236 volt, which is option 2. Moving on to the next question. The question says acetamide and ethylamine are distinguished by reacting with. Okay, so we have acetamide and ethylamine. So one is amide, one is amine. So which of the following reagents we can use to distinguish them? So the correct answer will be option 1, aqueous NaOH and heat. So what happens is when we react amide with aqueous NaOH, ammonia gas is released. So ammonia gas is released and ammonia has a distinctive pungent smell. So we can identify the loss of the ammonia gas. Whereas when amines are reacted with a base in and heated, so no reaction takes place. So correct answer will be option 1. Moving on to the next question. The question says a white crystalline substance dissolved in hot water and on passing H2S in solution, a black precipitate is obtained. Okay, so it is a practical chemistry question. So we'll just go step by step. Okay, so first of all, we have a white crystalline substance and it is dissolving in hot water. Okay, and when we pass in H2S, we get a black precipitate. The black precipitate is completely dissolved in hot HNO3. Now adding a few drops of concentrated H2SO4, a white precipitate is obtained. Okay, so we have plenty of information. So let's start with the first one. We have been given that the crystalline substance is dissolving in hot water. Okay, so cadmium sulfate, it is insoluble in water, so we can eliminate it straight away. Okay, we can also eliminate BaSO4 because barium sulfate is also insoluble. Then we have that when we pass it to H2S in solution and we get a black precipitate. So the black precipitate, it is completely soluble in hot HNO3. So the sulfate, okay, so when we pass H2S gas, sulfide is formed. Okay, so we'll have sulfide of SRS, right? And we have PBS, or we'll have barium sulfide. Okay, so the sulfides of strontium as well as barium, they are not soluble in either hot or cold HNO3. So we can also cancel out strontium, so we get the correct answer as lead chloride. Okay, so PbCl2 will be our correct answer. If we have to confirm it, we'll just go through it because we are passing H2S in gas and a black precipitate is formed, and we know that lead sulfide, it is a black precipitate. And when we add a few drops of H2SO4, so in that case PbSO4 will be formed, and PbSO4 forms a white precipitate. Okay, so the correct answer will be PbCl2. Moving on to the next question, the question says, for a reversible reaction, A solid plus B gas gives 2C gas at any temperature T. The relation between Kp and Kc is given as Kc is equal to Kp multiplied by RT raised to the power x. Okay, so we know the relation between Kp and Kc is given as Kp is equal to Kc multiplied by RT raised to the power delta Ng. So delta Ng is the change in the number of moles of gaseous molecules, right? So if we find out delta Ng, it will be the number of moles of gases in the product side, which is 2. Right here we have 2C minus the number of moles of gaseous reactants, right? So which is 1. We have only one molecule of B. So 2 minus 1, we give delta Ng as 1. So the relation between Kp and Kc will be as Kp is equal to Kc multiplied by RT raised to the power 1. But in the question we have in terms of Kc, right? So if we just take RT to the other side, we'll get Kc is equal to Kp multiplied by RT raised to the power minus 1. So the value of x will turn out to be minus 1, which gives us correct answer as option 3. Moving on to the next question, the question says D-glucose and D-galactose are, okay, so we're talking about epimers. So what are epimers? As we know, in glucose we have 6 different carbon atoms. So epimer is a compound where the configuration is changed only at one chiral center. Okay, when the configuration is same at all different centers, but at one chiral center the configuration is reversed, right? So in that case an epimer is formed. So if we talk about D-glucose and D-galactose, so these two molecules are C4 epimers, which means that at the fourth carbon atom there is a uh, there is an inversion in the configuration only at that specific carbon atom. Okay, moving on to the next question, the question says, among the choices, which element will always show a +3 oxidation state? Okay, so we have to tell which of the following elements will show a +3 oxidation state. So first of all we have vanadium. So vanadium shows multiple oxidation states like +2, +3, +4 and +5. So we can remove this. Other options that we have thorium. So thorium shows 2 oxidation states, which is +4 and +3. Okay, so we have +4 and +3 oxidation states. So it also shows multiple oxidation states. Then we have actinium. So this will be our correct answer because it shows only one oxidation state, which is +3 oxidation state because of the inert pair effect, right? Because we have actinium is present in the very low in the periodic table. So and also the f orbital has been filled until then, so that will only exhibit +3 oxidation state because it has 3 electrons in its d subshell. Okay, so moving on to the next question, the question says a graph is plotted between molar conductivity of various electrolytes NaCl, HCl and NH4OH and root C. Okay, so the graph has been plotted between molar conductivity versus the root of concentration. So we have to match the following that which of the following graph is of which of the following electrolyte. Okay, so if we take a look at the graphs, so we know that when we draw a graph between molar conductivity and root of concentration, so for a strong electrolyte we get a straight line, whereas for a weak electrolyte we get a curved graph like this, right? So that means that the compound 3, it will be a weak electrolyte, which is NH4OH. So we can eliminate options 4 and option 3. So now we have to figure out which of the following will have a which will have a higher molar conductivity, NaCl or HCl. Okay, so because the anion is similar. Okay, so anion is similar, so we have to compare the sorry, we'll have to compare the conductivities of the cations, which is Na plus and H plus, right? So you have Na plus and H plus. So the conductivity of H plus is higher than Na plus. So that will mean that the conductivity of HCl will be greater. And if the conductivity of HCl will be greater, so it will be the 1, right? So 1 will be HCl, 2 will be NaCl, and 3 is NH4OH. Correct answer is option 2. Moving on to the last question of section A. Which pair of elements does not demonstrate a diagonal relationship? So what is a diagonal relationship? Is that if I draw the periodic table a bit, okay, not the entire, I'll just draw the S block here, okay. So here we have hydrogen, then helium, then lithium, beryllium, boron, and so on. So here we'll have boron, and here we'll have sodium, magnesium, and I'll also draw aluminium. Okay, so what happens is in a diagonal relationship, the okay, so the upper element, it shows a diagonal relationship when we move towards the downward element in the next group. Okay, so the properties of lithium and magnesium will be similar. So this is a diagonal relationship. Similarly, if we go diagonally down from beryllium, we'll get to aluminium. So the relationship between beryllium and aluminium will be also a diagonal relationship, and they will show similar properties. Similarly, if I talk about boron, so if I go to the next atom diagonally in the group, so we'll have silicon there. So boron and silicon will also show a diagonal relationship. However, there will be no diagonal relationship between boron and magnesium because it is in the opposite direction. Diagonal relationship is working towards the right hand side towards the next group. Okay, so the correct answer will be option 3, magnesium and boron. They do not demonstrate a diagonal relationship. So that is it for the section A. Take a short break and then come back for the section B. So starting with the section B, we have question number 86. It's an assertion reasoning type question. So the assertion says half time t for first order reaction is dependent on temperature. Okay, and the reason statement says on increasing temperature, rate of reaction and rate constant increases. Hence, half lifetime of any reaction will decrease. Okay, so if we talk about the half life of a first order reaction, so the half life is given as t half is equal to 0.693 divided by k. 0.693 divided by k, and k is the rate constant. Okay, so if we talk about the relation between half-life and temperature, so if we see that the half-life is dependent on the rate constant, but we also know from the Arrhenius equation that the rate constant depends on the temperature as well, right? When we increase the temperature, generally the rate of reaction will increase, and when the rate of reaction increases, the rate constant will also increases, right? So if the rate constant will increase, that means that the entire value of the half-life will decrease. Okay, so both the assertion and reasoning statement are correct, and they give us a correct answer as statement 1 because the reason also explains the assertion. So assertion and reasoning both are true, and the reason is the correct explanation of the assertion. Moving on to the next question, the question says complex of which color is produced in the nitroprusside test of sulfur. Okay, so when we carry out the sodium nitroprusside test of sulfur, say we have when we form the Lenzanius extract, we get Na2S. Okay, so a violet complex is formed, and that is characteristic of presence of sulfur in an organic compound. So the correct answer will be option 3, violet. Moving on to the next question, the question says arrange the following halides in the correct order of increasing covalent character. Okay, so what happens is the order in this question is based on the concept of polarizability. So as the size of the halogen atom increases, so the ionic character will keep on decreasing, right? So when the size is increasing, so the electronegativity is decreasing, right? So when the electronegativity decreases, the ionic character of the halide will keep on decreasing, and the covalent character will keep on increasing. So if we talk about that, so when we move down the group, the covalent character will increase. So it will be highest for bromine, then for chlorine, and it will be the least for fluorine. So the correct option will be option 4, AlBr3 maximum, then AlCl3, then AlF3. Moving on to the next question, we have an assertion reasoning type question. The assertion says from the value of psi square at different points within an atom, it is possible to predict the region around the nucleus where electrons will most probably be found. Okay, so we discussed in the first question of chemistry in this test that the value of psi square, which is the probability density function, so it gives us the probability of electron which can be present in a given region. So the statement assertion statement is correct. If we take a look at the reasoning statement, it says with the help of quantum mechanical model of an atom, the exact position of an electron in an atom can be determined. So we all have studied the Heisenberg uncertainty principle, and from that we know that we cannot determine the exact position or the exact velocity of an electron at any given point of time. So that means the statement R is incorrect. So the correct answer will be assertion is correct and reason is incorrect. Option 3 will be the correct answer. Moving on to the next question, the question says the products of the given reaction are. Okay, so here we have anisole and it is being reacted with HBr. So what happens when we react with HBr? HBr acts as an acid. Okay, so it will give us H plus and Br minus. Okay, So what happens is, first of all, the H plus will attack. Okay, so when the H plus attacks, where will H plus attack? We have a lone pair on this oxygen atom, right? So H plus goes and attack on this oxygen atom. So what is formed is, we have this benzene ring. Okay, so we get O, here we get a H plus, and here it will be a CH3. Okay, so now if we take a look, there will be a double bond character in this bond between the phenyl ring and oxygen. Okay, so this is a stronger bond, whereas the bond between oxygen and CH3 is a weaker bond. So this bond will break and the electrons will go to oxygen. Okay, so what we get is, we get a phenol. A phenol is formed here along with a CH3 plus. So the CH3 plus, it will go and pick up this Br minus. So we get phenol and CH3Br formed in the following reaction. So the correct answer will be option 4. Phenol and CH3Br will be formed. Moving on to the next question. The question says, which of the following molecules exhibits sp3 dehybridization with one lone pair of electrons on the central atom? Okay, so sp3 dehybridization, that means we need to have four hybrid orbitals, and that means, and along with one lone pair. So that means we'll have we'll have a total of four hybrid orbitals, right? Really sorry. In sp3d we'll have five hybrid orbitals, right? Five hybrid orbitals, and out of those five we'll have four bond pairs, and one will be a lone pair. Okay, so let's take a look in SF4, right? In SF4 we have sulfur as the central atom. So sulfur has six valence electrons, right? It has six valence electrons, so four will be used to bond up with one fluorine atom, right? Each, and two electrons will be left, so that will be in a lone pair. Okay, so a square planar type of compound is obtained. So SF4, it will be in the sp3 hybridization with one lone pair on the central atom. Next, if we take a look at PCl4 plus, okay, so PCl4 plus is in a tetrahedral geometry, right? What happens is, phosphorus has only five valence electrons. So when it forms a bond with three chlorine atoms, right? So then it will have a lone pair. But if a fourth chlorine atom is being incorporated, so what happens is, the lone pair is used up in making a covalent bond with the chlorine atom. So there will be no lone pair on the PCl4 on the central atom available. So 2 will not be our answer. Taking a look at the next, we have XeO2F2. So what is happening in XeO2F2? Xenon is the central atom. It has 8 electrons. Okay, so one electron each will be used to form a bond with fluorine, right? And oxygen, right? Oxygen forms two bonds. So there will be a double bond with oxygen, but it will contain only one hybrid orbital. Similarly here, and so six electrons have been consumed, one electron remaining, that will be a lone pair on this atom, and we have an sp3d hybridization. So 3 will also give the similar. And if we take a look at ClOF3, so chlorine has seven valence electrons. Okay, so it will form a double bond with one oxygen, right? Then a single bond with one fluorine atom each. So this gives us four bonds, and there will be one lone pair. So 4 also gives us sp3 hybridization with one lone pair of electron on the central atom. So the correct answer will be 1, 3 and 4, which is option 2. Moving on to the next question, we have a match the columns type of question, and it talks about significant figures. Okay, so I hope, right, what I feel is that most students hate this concept of significant figures because it might be confusing sometimes. Okay, so let's discuss this question. So in column 1 we have four different quantities, and we have to tell how many significant figures are present in them. So if I take a look at A, we have 0.0052. Sorry. Okay, so in this case the number of significant figures is 2. Okay, so what happens is that the zeros which are present on the left side of the numbers, right? If we have an actual number, right, 1 2 3 4 5, anything, so the zeros which are present on the left side, they are insignificant. Okay, so the significant figure will be 5 and 2, 52. So A will have two significant figures, it will be matched to P. Now if we talk about 2.005, so the zeros which are present between two other numbers, right? When the zero is present between two natural numbers, so those zeros are considered as significant. So A will be matched to P, B will be matched to R. Okay, so let's just write it down. A will be matched to P, B will be matched to R. Okay, so now in statement C we have 200 eggs. Okay, So this feels weird, but when we have a specific quantity, right? When we have talking about distinct quantities, when we are counting things, for example, I have say 20 eggs or I say 20 bananas. So in that case, what happens is we have a distinct number. So after in that we can add infinite number of zeros after the decimal place, and the zeros that are being added after the decimal place, they are significant figures. So we'll get C will be matched to S, that is infinite significant figures. And if we talk about 4.01 multiplied by 10 raised to the power 2, so we'll just take a look at this portion, right? And in this we have 4, 0, and 1. Both, all three will be significant figures. So D will be matched to Q. So we have C matched to S and D matched to Q. So this gives us the correct answer as option 3. A, P, B, R, C, S, and D, Q. Now, moving on to the next question. The question has we have a phenol which is being reacted with chloroform and NaOH, and in the second step, it is being acidified to give A as the major product. Then it is being reacted with Tollens reagent, and we get a silver mirror plus B. And then B is being reacted with acetic anhydride to give a final option answer, final product C. So we have to identify the product C. So when we react phenol with chloroform and NaOH, so this is the mechanism for the preparation of salicylaldehyde, and it will be obtained as the major product. And when we react it with Tollens reagent, so what happens when an aldehyde reacts with Tollens reagent is that the aldehyde is oxidized. So the Tollens reagent oxidizes the aldehyde to a carboxylic acid. So we'll get salicylic acid, and when that is reacted with acetic anhydride, so this is the mechanism for the preparation of aspirin, and aspirin is also known as acetyl salicyl aldehyde, oh sorry, salicylic acid. So final product C will be acetyl salicylic acid, which is also known as aspirin. So the correct answer will be option 3. Whereas some might have a question, what is oil of wintergreen? So oil of wintergreen is just a common name for methyl salicylate. Okay. Moving on to the next question, the question says, which complex exhibits the highest value of spin-only magnetic moment among the following options? Okay, so we have to find out the complex with the highest value of the spin or only magnetic moment, and we know that the spin only magnetic moment will depend on the it will depend on the a number of unpaired electrons in the compound. So more is the number of unpaired electrons, more will be the spin only magnetic moment. Okay, so if we take a look at the compounds, we have NiCO4, PtCl4 2 minus, NiCl4 2 minus, and CuCl4 2 minus. So among these compounds, NiCl4 2 minus will have the highest spin only magnetic moment, because all the other compounds, they have a zero magnetic moment. They have a completely filled d orbital, and no there is no unpaired electrons in them, right? Why? Because in nickel CO4, in NiCO4, CO4 is a strong field ligand, right? So CO4 is a strong field ligand, so all the unpaired electrons will be paired, leaving behind zero magnetic moment. For PtCl4, so what happens is, as we keep on moving down the group in d orbitals, so even the weak field ligands, when we are talking about the 3D series, so the weak field ligands which are present in the 3D series, when we go down to 4D or 5D, so the weak field ligands also act as strong field ligands. So all the electrons in PtCl4 2 minus will also be paired, giving it as zero magnetic moment. For NiCl4 2 minus, what happens is that the chlorine acts as a weak field ligand, and therefore we get zero magnetic moment. Oh, sorry, non-zero magnetic moment, because it is a weak field ligand and will have number of unpaired electrons. Whereas for CuCl4 2 minus, copper has a D10 configuration there, right? So there will be no unpaired electrons and it will have a zero magnetic moment. Moving on to the next question, the question says, consider the statements given below. For the spontaneous cell reaction, E cell is greater than 0 and delta G is less than 0. Okay. Statement B says, Kohlrausch law of independent migration of ions is applicable for strong electrolytes only. Statement C says, in a mercury cell, the product at cathode is mercury liquid. Statement D says, the conductivity of electrolytic solution increases with increase in temperature. Okay, so we have to select the correct option. Okay, so when it's the correct option. Okay, okay, so we have to tell which of the following statements is true and which is false, right? So the statement A says, for spontaneous cell reaction, each cell should be greater than 0 and delta G should be negative. So we know the criteria for spontaneity is this only, right? That change in free energy should be negative and change in the cell potential should be positive. So this is a true statement. Statement B says Kohlrausch law of independent migrations is applicable only for strong electrolytes. This is a false statement because Kohlrausch law is applicable both for strong electrolytes as well as weak electrolytes. So this is a false statement. Statement C says in a mercury cell, the product at cathode is mercury liquid. So this is the correct statement. Okay, so this will be true. So what is happening in a mercury cell, that uh, liquid mercury in its elemental form is formed by the reduction of the mercuric oxide. Okay, so it is also used in many kinds of batteries. So this will be a true statement. And the final statement says the conductivity of electrolytic solution increases with increase in temperature. Okay, so when we increase the temperature, conductivity will increase in the electrolytic solution because the temperature increases. So that will mean that the ions will have more kinetic energy, and when they will have more kinetic energy, they will move faster and more freely. So this will be a true statement. So we have TFTT. So this will be option 2. So option 2 will be the correct answer. Moving on to the next question, identify the correct statements about the product's form. Okay, so a reaction is taking place. We have bromine and NO2 on the phenyl ring present at meta positions to each other. So when we react this with magnesium in the presence of ether, what will happen? A Grignard reagent is formed, right? So Grignard reagent will be formed. So after the Grignard reagent is formed, it is reacted with dry ice. Okay, so when a Grignard reagent is reacted with dry ice, what happens is that the CO2 group, it comes and attaches to the carbon atom to the alkyl chain, right? So there will be a carboxylic acid will be formed. So this can be seen in the mechanism also. Compound B is a carboxylic acid with NO2 at its meta position, and then when it is reacted with B2H6, so B2H6, it is a reducing agent. So it is a reducing agent. So what happens is it will reduce the carboxylic acid to an alcohol. Okay, so the correct answer will be option 2, as C is this. Okay, moving on to the next question. The question says which oxy acid upon hydrolysis yields peroxymonosulfuric acid. Okay, so first of all we need to understand what is peroxymonosulfuric acid. So peroxymonosulfuric acid is H2SO5. Okay, so it is not a well-known compound because it is a unstable intermediate. Okay, so it is formed as an intermediate during the hydrolysis of H2S2O8. Okay, so when the hydrolysis of H2S2O8 is occurring, so peroxymonosulfuric acid is formed as an intermediate, and then it is unstable, so it dissociates to form H2SO4 plus H2O2. Okay, so the correct answer will be H2S2O8, as this intermediate is formed during its hydrolysis. Okay, moving on to the next question. The question says for the complete combustion of 280 kg of C4H8, the required amount of O2 gas is. Okay, so first of all we'll need to write the balanced equation for it. So the balanced equation for combustion of C4H8, which is butene, right? So the combustion of butene will be as C4H8 plus 6 moles of O2 gives 4CO2 plus 4H2. So 1 mole of butene, right, it will require 6 moles of O2. Okay, so we have been given the mass of butene present. So we have 280 kg. So if we convert it to number of moles, we'll divide it by the molar mass, which is 56. So we get the number of moles of butene as 5 into 10 raised to the power 3, or 5000 moles of butene is present. Okay, so that means 1 mole of butene requires 6 moles of oxygen. So 5000 moles of butene will require 30,000 moles of oxygen. So we need 30,000 moles of oxygen, but the we need to find out the amount of oxygen needed in kg. So what we'll do is we'll multiply the number of moles by the mass of oxygen. So the molar mass of oxygen is 32, because we have oxygen gas, it's O2. So 16 into 2 will have the molar mass of oxygen gas as 32. So when we multiply it, we get the weight of oxygen required as 960 kg, which is option 2. Moving on to the next question, we have a match the following type of question. We have 4 different mixtures, right? We have methanol and ethanol, phenol and cyclohexanol, right? So we have 4 different mixtures, and we have to tell which of the following tests can be used to separate or distinguish the 2 given compounds. Okay, so first of all, we have methanol and ethanol. So if we talk about methanol and ethanol, we have CH3OH and we have CH3CH2OH. Okay, so both are primary alcohols, both will react similar to Lucas reagent, both will act similar to sodium metal, and both are not aromatic, so they'll not react with ferric chloride. So, but ethanol, right? We know ethanol is an alcohol that gives an iodoform test. Generally, iodoform test is given by methyl ketones, but ethanol is an exception. It gives the iodoform test as well. So, A can be separated using methanol and ethanol can be distinguished using the iodoform test. So using that, straight up the answer becomes option 4, because in none of the other we have A as R. So when you are attempting the question in an exam, so use this, just check the options to eliminate the answers faster, eliminate the options faster and get to your answer quicker. Okay, so but we'll go through all the options as well. So we have phenol and cyclohexanol. So I just talked that ferric chloride test, right? Ferric chloride test, it is used to distinguish between aromatic and non-aromatic compounds. So only aromatic compounds give the ferric chloride test. So phenol will give the test and cyclohexanol will not. So B will be matched to S. If we talk about N-butyl alcohol and tert butyl alcohol, okay, so they can be distinguished using the Lucas reagent, because they are one is a secondary alcohol and one is a tertiary alcohol, and the tertiary alcohol gives instant turbidity when reacted with Lucas reagent, whereas N-butyl alcohol, which is a primary alcohol, does not give a turbidity instantly. So we get C will be matched to P. And if you talk about methanol and diethyl ether, so ether will not react with sodium metal. Okay, whereas the alcohol, which is methanol, it will give an effervescence when it reacts with sodium metal. Okay, so D will be matched to Q. So the correct answer is option 4. The final question of this full test 1 of chemistry portion, it says which of the following lanthanide ions exhibits paramagnetism? So we have La3 plus, Ce4 plus, Lu3 plus, and Gd3 plus. So Gd3 plus will exhibit paramagnetism because it has unpaired electrons in its 4f orbital. Okay, so for this you will have to remember the electronic configurations of some F block elements. So majorly these are the most important one. Okay, lanthanum, cerium, lutetium, and uh, GD. And there are 2 to 3 more F block elements that you need to know the electronic configuration to. And if you are familiar with the electronic configuration and properties of 7 to 8 major F block elements, you'll be good with the F block element questions. Okay, so the correct answer for this will be option 4. So that is all for the full test 1. Hope you all understood well, and we'll meet again for the next test, which is full test 2. Until then, keep studying, keep learning. Thank you.